So welcome to this presentation. My name is Christian Kreyenschmidt, and together with Bernd, Hobbie and Sebastian Hollermann from the Jade University of Applied Science, we make the paper that is called Intersection of an IFC Model with Information from Tracked Motion Path in a Building. So the motivation for this paper came up in a project which is called the Center of Competence for Planning and Building. So in German it is Kompetenzzentrum Planen und Bauen, where are actually a lot of institutions all around Germany that support small and middle-sized enterprises to get involved with new technologies and, of course, BIM. For the small and middle-sized enterprises, one way to get in touch with these new technology is that we do small implementation projects where we apply existing solutions. And in a hotel project with around 106 rooms, we came up with the question how to enrich an IFC model with information from a site inspection, for example. So when we take a look at the state of the art, we see actually a lot of technologies for IPS. But on the construction side of smaller projects, you don't have the needed hardware conditions like sensor, or sometimes you don't even have internet. That means during the erection phase we need something that can be weared by the people. Of course, the elephant in the room is that you use just your smartphone for that, and we cited some papers which describe that the improvement of a smartphone based on autonomous IPS in combination with machine learning algorithms to minimize the measurement errors has the potential to become the standard in the upcoming years. But nevertheless, we used an autonomous system that is developed by Internal Elements. It's a company from India, and the motion sensor consists of a shoe-mounted inertial measurement unit, an IMU, and a pedestrian dead recording system. And for real-time indoor localization. The system tracks the motion data in step frequency, and this is typically just generating a few dozen bytes. It calculates the displacement and transmitted the data by Bluetooth to an Android application, and this whole system works offline. So here we see a simple schema we created for the whole process. So as I said, the tracking is done by an autonomous system and take the information from every tracking point. And you see this on the left side of the slide. And the tracking data is generated with a text file, and we do the export with the Dropbox to a database, and then you have already the data on your system. And after that, we want to intersect or to superimpose that with the IFC model. And here you see here you see an image of the shoe-mounted device on the left side and a snippet from the generated data during the inspection in a text file on the right side. There is a timestamp which indicates the exact time per detected step. The columns X, Y, and Z describes the difference between every step, which is generated live, and there is no movement in the Z-axis. That means that we walk on one floor. I think that it sounds logical. That it's just taking the data every step. And the last column shows the so-called tag name, and here we take the points of information, which means nodes or individual information during our inspection. The created algorithm loads the tracking points to an IFC viewer as an object or as objects. The problem is that we have to align the IFC model with the tracking points, but the good thing is that the tracking points are imported as one container. This allows translations and rotations of the objects in a related set to align the starting points of the path with the starting point of the IFC model. We use the georeferenced coordinate system of the IFC model. That means, of course, the IFC model has to be georeferenced. In the second step, we have to rotate the path in the correct angle to align the models. So therefore, we use the reference point, which is taken during the path. It could be any marking point to align the process. It's just include in this alignment process is also included in the import algorithm. So that means that will happen automatically. And yeah, this is the result actually from the import. And here you can see the imported track in the IFC model. And we start here at the left side, with the starting point. And then we create a path which is recorded with points of information like damages or any kind of information. As I mentioned here earlier, of the room 28, we create a reference point to align the models. Now we want to intersect the both models and bring the recorded information from the tracking points in the IFC model. And therefore, the IFC viewer offers the comfortable possibility to suppose objects by collision detection. So we use this functionality to map the information of the corresponding room number or room name. And now the tracked points are extended by the attribute of the room name or room number. You see that here in this little image on the right side. Every tracking point has now a room number. And in the second step, to map the information such as images or damages or comments or something else to the specific tracking points, we superimpose between their timestamps. So please, for further details, look just in the paper. Probably you question yourself about the accuracy of the IPS system. So the testing during this paper shows us that especially for longer tracks, so that means longer than 200 meters, and for more than 2 rotations, that means when you have staircases or something, you do a lot of rotations, then the system actually fails. So you see here a distance or a tracked path with 8 rotations, and 400 meters distance had almost 30 meters deviation. So the problem is the drift actually that leads us into the deviation. And the actual work of this paper is how to get over this deviation. And here's our answer for that problem actually. And let's take a look on a larger scale motion path. So in the first 2 steps, you see that we started from a defined point in our building. In this case, it is reference point 0. That means respectively reference point 7. So, and during the track, we take our informations as we've seen in slide 8. And then we set several reference points like showed in the slide 7 and split the entire path to 7 different subsections. Yeah, you see here on the downside these subsections, and export the tracking data into a JavaScript and separate the track in subsections. So, and every subsection here is actually a data container, and we can use these data containers like with the principle we used before. That means we calculate the angle of the rotation and rotate every container into the right position according to the reference points. And so the result is actually an implemented track with any length, or could be any length, to a room sharp intersection of tracked information. So for the future or the further development, we see the implementation of the algorithm without the workaround in the IFC viewer. For example, we can use for that the IFC.js toolkit or something like that for visualization. We are not sure about that. So thanks for your attention. And when you would like to play around with the data or the tracked algorithm or something like that, of course, everything is published here on GitHub. And yeah, so thanks for your attention and goodbye.